Today I'm going to start talking about multiplications of vectors. And there are two ways that vectors can multiply together. And I'm going to talk about one of them today, which is the dot product or the scalar product. So why is it called the dot product? Well, that just comes from the notation that we give this type of multiplication where we have some vector dot another vector. Now it's called the scalar product too sometimes because the output of this is a scalar value, which might seem weird, but we'll get into the definition here. So let's draw out two vectors. Let's say we have something like this. So we'll call this A and this B with some angle theta. Now let's define what the dot product is. So A dot B we can say is equal to the magnitude of A times the magnitude of B cosine of theta. And so this is what we call the geometric definition of the dot product. There's another definition which I'll talk about in another video, but this is the geometric definition. And what this is saying in words is that A dot B is the magnitude of A times the component of B in the A direction. So if we draw a line, we have our BX component here along this axis. And what we're doing is basically taking A magnitude times Bx. And that's your dot product, which is a scalar value because this magnitude is just a number and this is just a number. Now the dot product has the property that A dot B is equal to B dot A, capital A, which if I draw this out again with A and B, that would just be the same as this. So B dot A is equal to B times the component of A along B. So B, and that would be AX, or A along B, sorry. There's not really a way to write that, but it's the same thing, basically. You just flip the values. Okay, so let's look at some properties of the dot product. And to do that, let's look at properties of cosine, because these are just scalar values. What about cosine? How does that behave at different angles? Well, if theta is between 0 and 90, cosine of theta is greater than 0. So this is 0 to 90 degrees. If it's between 90 and 180, cosine is less than 0. So it's negative. So positive, negative. What if theta is equal to 90? Well, then cosine of theta is 0. If theta is 0, cosine of theta is 1. And if this is negative 180, or just 180, cosine of theta is negative 1. So how can we do this, or how can we look at this and come up with the properties, the behavior of the dot product? Well, let's look at our equation. If this is great, let's use this because this example is less than 90. Let's do one between 90 and 180. If we look at this, we have some angle. This is A and this is B. So the component of Bx, remember we're taking, if this is the x-axis, we're taking the magnitude of A times the x component of B. But this x component of B is not along the same direction as this A component. It's to the left of it. And so therefore, it's negative. So it should be negative. Whereas in this case, the component here is along the same direction, and so it's positive. What about 90 degrees? If theta is 90 degrees, it looks like this, A and B. Now the component of B along A is 0. There's no overlap anywhere along here. It's just this straight line. Therefore, it makes sense that A dot B is 0. Now if it's 0, you have A, and then on top of that you'd have B, and it equals 1, which means A dot B is just the magnitude of A times the magnitude of B, and it's positive because it's along in the same direction. And it's also a maximum, which makes sense because the only component is along A. There is no other component. So then the magnitudes would simply just multiply together. Then finally, similarly, the opposite would be true. In this case, you've got A, and then you got B, which is the same thing as this. It's just in the other direction of A, so it would be negative. And so those are a few properties of the dot product. And in the next video, I'm going to derive from geometry how we arrive at this equation for the geometric definition. Thanks for watching.